All right, hey guys, HackerSploit here, back again with another video. And in this video, we're going to be taking a look at malware analysis. And for this particular video, we have our latest guest, and that is Amr Thabet. Now, Amr Thabet is a malware researcher and has worked with or in Symantec in their attack investigation team, dealing with major attacks from the NSA, like the Region and the Stuxnet, and was one of the people who actually converted part of its source code. He has also worked on the North Korean attacks, the China attacks on US corporations, and much more. He's a speaker in multiple conferences, including DEFCON, Bulletin University of Sydney, and he's going to be here making a few videos for us on malware analysis. So a huge welcome, and thank you for joining us on today's video.
Thank you, Alexis, and it's a pleasure to be here. So today, actually, I know this is maybe one of the early videos in malware analysis for the channel. So I want people to give them a taste of malware analysis, like how malware analysis looks like and if it's a good fit for them, for their career. So I know that maybe some people are starting and planning to start their career in malware analysis, and really there is not lots of good resources there. People tend to go with their cybersecurity mentality of getting lots of certificates, or let's say staying 5 years in SOC and then 3 years as pen tester and then 2 years or incident handler and then move to malware analysis. It's the final beast of the whole cybersecurity chain. And they take actually a really long time, and really there's no lots of help there. So for what I actually did is that for myself, I started with mechanical degree. It was totally far from cybersecurity. I didn't have any certificates, and I went and I was actually able to make that. I was actually able to work in Symantec or speaking in a big conference, and I discovered that what can make you able to do that. I have made a webinar for this type of people, because it's really sad when I see people going into that lots of far directions and taking this long curve. And I have created a webinar that actually teach everybody how he can go from being completely zero in early stage in cybersecurity into able to get at least an interview every single time. I actually in the webinar, I create your own CV in front of you. So if every step, you have seen it, Alex. How do you think about it?
Well, as I mentioned to you earlier before, it truly is an excellent resource, especially for those who are looking to get into it but don't know where to start. So yeah, definitely, it's a fantastic starting point, and really it covers everything. That was the good surprise that I did find with it, is that it covered everything that one would need to know to actually get started and, of course, move on into the profession.
Thank you. I will actually, maybe we can include the link for the people somewhere in the video or in the description.
Yes, the link will be in the description, and it should come up in an annotation just about right now.
Perfect. So today we will have this simple exercise. It's more like a fun exercise, and I like it because it's okay, for malware analysis, people think it's all black and white screens and so on. So we'll have something has more colors and fun. It's actually a challenge by FireEye. It was last year. They have a CTF when they have different malware analysis exercises that is a bit close to the reality, or there's something from the real attacks. And this is one of the challenges. It's called Ultimate Minesweeper. It's basically one of the games that we have seen all of our childhood that we never able to solve. And this one has 897 bombs. If you calculate, yeah, it's if you calculate here, it's all 900 bricks, but it has 897 bombs. So you can't manually find the right 3 ones. If you click here, you get a bomb fail. Wherever you click, you get a fail. So what to actually do with this exercise? If we assume this is a malware, let's say if this is a sample, this is a malware sample, the first thing what you will think about is that let's do the basic static analysis. let's check the strings, the text. What text it have? Does it have URLs? Does it have like the key? Does it have like the number of this, the bombs names or numbers? What can have with the strings? Or other than the strings, we can check the BE header, because BE header gives us so much information about the application. Like if it's a virus, we'll know like what it connects, what URLs it connects to, what commands it uses, does it connect to the internet, maybe what type of protocol, even like HTTP or FTP. There will be like Windows commands, the names of the Windows commands, or what do you call it, APIs. You can really know like what it does.
All right.
You can also, yeah.
So I have one question. When performing your malware analysis, what would you start off with traditionally? Would you start off with performing a static analysis, and then move on to your PE headers, or what exactly do you find works best?
For me, I find what works best is at the beginning is the basic static analysis. I like to look at the malware analysis as 4 steps. I'm a bit different from what people think about. Like they think about it's static and dynamic analysis. But I have what's called basic static analysis, which basically it's like the things that you don't look at the code, but you look at text, you look at strings, you look at resources, you look at the BE header. The thing is, it's all around the characteristics of the file. Then you look at inside what's the file, because the code takes a long time to do the analysis and to get information out of it. So I mostly look at the basic information. For here, we'll not look at the text, but we'll look at the BE header, which is something we can do with a program called the BID. BID or PAID or whatever they call it. That's a very simple application to scan the BE header to get information about the structure of the file, what commands and so on. If you don't know what's BE header, for the people who don't know it, BE header is basically the structure of the file. Like for an exe application, for any file, it has like a structure. Here's the data, here's the code, here's the resources, the icon, here's the text. So this is basically the structure of it. And it includes also like not only the name of the sections, like this text, it means it's code, this resources, that means icons or something like that. It also includes all the commands it uses from Windows. And here, for example, it uses a library, it's a Windows library, an important library. It's called Microsoft Core or MS Core E. And this library only included in .NET applications. Like this structure, like only this library and this function or this command, this Windows command called core exe main, that is only used in .NET applications to load any .NET code.
All right. So when you're talking about the various libraries that you'll find, are there particular ones that you'll come across many a times? As you've just mentioned, when dealing with .NET, one of the ones to expect is the MS Core library. So are there any others that one might be paying or should be paying attention to that are important or that actually make a difference?
Yes, there is. The first one is the kernel 32. This is like almost all applications have it, but kernel 32 has very important commands to make you understand what is this malware is doing, what could be the possible actions it does. Like if it creates files, it has commands like, even the name of the Windows commands are very easy to understand without like actually being a programmer, like open file, create file. You can imagine what is that. It has also things like there's a library called WinInit, which is related to HTTP connections, mainly HTTP. I think they have for FTP, but I'm not sure. But mainly HTTP. And you can see like malwares who are using this library for HTTP connections. So you know that, okay, maybe they are communicating with their command control server through an HTTP URL, through like a website, like a normal website, or other libraries that do some modifications to registry. And things like that can tell you a little bit about what the application is doing. Some of them can be related to more advanced techniques like process injection, when he browsed through all the processes that's running and so on. So there's some common libraries, and through experience you'll start to learn what's the APIs that you're searching for.
Okay.
So for this one, also, what is good about this program PID is that they can tell you if this malware, if this file is backed or it's not. Is it encrypted or it's not? It's what's a compiler even, like is it compiled with C++, if it's compiled with .NET. It doesn't always succeed, as you can see here. But in many cases, it does find, like, let's say, normal backers like UBX, ASBack, and things like that. And there is also another tool called the CTF Explorer. It's even much better than PID, and it's stronger in finding that. Anyway, we have discovered it's a .NET application. So let's try to let's check the code of that application. You can see I didn't go deeper into the resources and so on just for this challenge. But for you, if you're analyzing a malware, it's much better to do like a really deep analysis. Anyway, so this is it. Sorry. And then there is an application very known for .NET called DNSpy. DNSpy is kind of a new tool, newish, but this tool is really, really, like, it includes everything you need about .NET. So it's a decompiler, disassembler, it's able to debug, it's able to batch the code, it's able to do so many things. It's able to read the code up here, or even the file information, able to debug the code and able to batch. This is like the most important thing you will need for any tool, basically. And we can load the ultimate Minesweeper. We just drag it up here. And here's our program. Here, as you can see, when you choose the application, it shows you all the main information, all the characteristics, assembly, and so on. And this is actually information added to .NET, so you don't see it commonly when you use a B header or when you use like a tool like BID, but it gives you like much information, like it's the name of it, the description, and so on. And here it also can able to check the B header, which will not go on to it now. And then you go into the Ultimate Sweeper program, and then you want to start analyzing. So where to start? The best start, there's two ways. You can read all the functions one by one, like going like sequentially, or you can go with the execution. So where's the entry point where the program actually starts? You can right click and then go to entry point. That goes to where the program actually starts. So go to entry point. You have here, let's say, here what the application do, the main function. The main function is always the function for starting the application or the malware or whatever. And then it does like enable visual styles, okay, set compatible, okay, we don't care. And then application run, create a new form.
Yep.
Main form, yeah. Usually, .NET applications have like a form, like usually in most of most of .NET, they have like a form or a window, and then everything goes from here. So we go to the main form, and here we see the actual start of the program. It's here's main form, or you can go here and choose CTOR. CTOR means the constructor.
Yeah.
And then we see what's happening in this exercise. Back to the exercise. So initialize components. This is like, okay, what's the label? What's the name of this? Blah, blah, all of that things. We can see here, like creating all the text box, creating the labels, creating all of this. We don't care about that. And if we go back, and then we have the main field. This is, let's say, the place that has and all the bombs. So we check what is this. It's actually looks like it's a class or like an object that represents the mines and so on. And then we see here in that code, he takes a variable called size. Maybe it's like the number of items or something. And then he set the size. He set here an array called mines present with size and the size. So it's an array, double array with the size and the size. So it's like a square.
Yeah.
And we know that mines is a square. And mines present, so this is the first list or the first array, then mines visible, and then mines flagged. We know if we opened this one, when this is all the mines, okay? If we click with the right click, this is the flag. I know this because I used to play this game and I used to fail in it. So I remember this type of flag. So let's say this is what he means with flagged. Let's assume that, right? Mines visible, we don't know. Maybe it's when we click on it, it becomes visible. And mines present is that there is a bomb there. Possibly, at least from the names, we can assume that, right? Then we continue. Okay, what is the size of this main field? It's main form and then this valloc mode limit. Let's see what is that. Valloc, it's 30. U means unsigned, so it's like a number, just a number. So it's basically 30. So we can say it's 30 multiplied by 30. This is the mines. It's like 900. And when we opened it, it was 897. So it's like only three places when it doesn't have bombs, and all the remaining are bombs. That's interesting. We need to find these three. Maybe we don't. Maybe we don't care about them. Let's continue. Then he goes to, after he creates the mines field and all of these arrays, he then go to a function called Allocate Memory. We'll look at it later. Remind me if I forget it.
All right.
It's important. And then he goes here to something called mine field control. He said the data source is the mine field. He then said, he then said something called square revealed. Callback as a word means always a function like a place that has code. So when you see callback is something interesting, right? Here it's let's say this is the code when maybe takes colon, takes it takes colon, it takes row. It is possibly when a square is revealed, like when you click on a square, maybe, and it takes the column, takes the row, and then it does some stuff. We can check it later. And then we have first click callback. So this is when you click again, but maybe when you click the first time and start some stopwatch and so on. I think it makes sense because when we click the first click, there's a stopwatch starts here. So that's possibly what this part is doing. Before we go into reading that part or dig deeper into it, let's check what's mine field control. What is that class or object? We go here, it's actually a variable for another object called mine class control. If we go here, it's something from user control. Maybe it's like the space, the area that has the buttons. Most probably like this area called user control, text box, like this type of stuff. And then it has the first click, the square reveal, the mines flagged. This is like, let's say, when there's a mine flagged. And then here he takes the data source, he save it. We have seen what's data source, it was the mine field. We can skip that. Here, let's say, oh, this is the depth in pixels. Okay, there's the size in pixels, it's fine. And then the start of it is basically initialize the components. If we looked at their components, we can see like, okay, here's the image list. Okay, here's like suspend. Okay, we can skip all of that. Here we see that we have some pictures like blank field, bomb, hidden. I don't know what's hidden. Flag, safe. Safe maybe means it's not a bomb. This is an interesting one. And then they have like a picture, place for a picture. Maybe all of this was actually a picture, one picture. And then some stuff. The size of it, the size of the picture is 600 by 600. Maybe this is actually the size of the whole, sorry. Maybe it's all of this is 600 by 600. I will not measure it, but yeah, you can imagine, right? Anyway, This is basically the main component. So it looks like this, the main field controller, it represents this area, this place where it has all the buttons and all the pictures. It has the, like the blank, the bomb, and so on. If we continue, let's continue checking the code of it. So we understand the size, the depth, the initialized components, okay. On layouts, this is basically maybe like designing the picture, like designing the place. Okay, it doesn't look like it does something useful. It calls just to the main color. And then here, mean full paint. This is how he paint the full picture that we see all of these bombs. So he say here, we take the graphics, okay, we initialize the graphics, draw the picture. The picture box one that is was size 600 to 600. We know this is the size, that's fine. And then here we go into interesting part. So here he say number is 0, okay. While this one is less than the data source. If you remember back then, sorry, we have lots of back. Yeah. The data source was actually the minefield.
Yes.
So this is very important for us, right? If anything that is playing with the data source, that means something could be very important because it's related to the bombs that we need to understand, right? So here he say he loop on all the from 0 to the size. So from 0 to 30, because we know the size is 30. This is like the number of rows. And then num2 is from 0 to the size as well, loop until it's equal to size or higher. Here we see, right? Here, if the mines are visible, let's say this is the row, this is the column, let's say, if it's visible, and if there is a mine present, draw a picture. If this is the mine present in the same place, so if there is a bomb and it's visible, draw this picture. If it's not visible, or is it not, so it's not a bomb, draw another picture. This is the picture number 1. This is means it's a bomb. Picture number 4, that means it's not a bomb. And if it's not visible at all, but it's flagged, draw this picture. That means draw the picture number 3. Okay, let's see, we have seen all the 4 pictures in the list. So we can go back to this list actually and see what is picture 1. Picture 1 is the bomb, picture 4 is not a bomb, looks like, and picture 3 is flagged. We can go here and we see, okay, 1 is bomb, yes. 3 is, 4 was not bomb, so it's safe. It looks like this means not a bomb. And picture 3 was flag. I don't know what's picture 2 really, but we can ignore this for now. And then, okay, this is paint. So basically paint does all the drawing of all the bombs we have seen. Then the mouse right click. This is there's more functions? Well, I think we don't have more functions. Dispose and then initialize, and that's it. So with the right click, again, you take a number 1, number 2, and it's basically here Y and X. This is where you did click, you did the right click. You know, this is like where you actually click the X and Y. And then he tries to know which cell exactly did you click on. So he say, let's say if it's on the X number 20, but the cell is like 10, so it means you clicked on the second cell, kinda, you know. So this is how he tries to calculate the cell. He gets number 1, number 2. If it's if you clicked with the right click, then he set the flag. So bool flag equal this. So if you have a flag already, and if you did or you didn't, you see here he gets the actual value of the flag, if you have flagged it or not, if it's true or false. And then he said, this data source flag with this X and Y, this cell, the row and column, put it the opposite of the actual value of the flagged. So if it was flagged, make it not flagged. If it's not flagged, make it flagged. We can see it up here, like right click, another right click, remove it. Right click, another right click, remove it. So we can understand this part. Then, I don't know, invalidate, whatever. If this mine flag not null, this, okay, we understand this part. Anyway, we go to the left click. This is more the important one. When we click and we get exploded. The first is gets another flag. Okay, if it's visible. If it's he first get this flag, but he set the visible to true. So if wherever it's visible or not, he set the visible to true. And then he say that if it's not flagged, and there is, you remember the squirrel revealed callback. So here he goes again, and he check if this squirrel revealed is not null, then calls to squirrel revealed. So it looks like when we click left click, he gets the flag anyway, and then he set it to true. So he shows us the bomb, mostly because it's mostly we see the bomb. And then he calls to square revealed and give it the row and the column. So here, okay, now we understand almost how it works. And then he does some things related to, okay, here's the click happened first. Here he calls to first click happened and then first click. So whatever the click you have clicked, or whether it's left or right, I think, yeah, he checks if it's left and right. He just click on, he just go to execute the first click, which you remember when he started the stopwatch and so on. Sorry. Start the stopwatch and so on. So this is basically the scenario that's going with this application. Of course, we do here like a sequential analysis. When you do a malware, like, sorry, we're trying to get into the malware and comparing. When you get into the malware, you don't usually do that full analysis. It may take you 3 weeks to do that, but you actually sometimes just want to answer specific questions. What IP it connects to? Does it have a resistance? Doesn't have this? Doesn't able to remove itself? Doesn't modify the registry? Doesn't escalate privilege? Doesn't? So sometimes you only have some questions. For us, today we have an exercise, so we go through the full analysis. Sometimes the full analysis for a malware can take like, some malwares stick with me like half an hour, the full analysis, so it doesn't matter really. But if it's a huge malware, you think about what exactly the questions that you want to answer.
All right.
And you go with that.
So when it comes down to the different types of malware, are there different sets of questions that you might want to ask depending on what system they target and operating system?
Well, the main questions you usually ask are not related to the system, but are related to the reason why we want this report. Because at the end, malware analysis has a business value. People usually, when they do malware analysis as amateurs, they forget about this. Malware analysis has a reason. It's there. It has a business value. If you're an incident, let's say, you want to know how this attack had happened and what impact it can bring to the system, what exposed other systems could be. Let's say if it infected one machine in the network, does this malware able to infect other machines? Does it able to infect the router? Does it able to escalate to reach the server? How much control it gives to the attacker? This is good questions to know what impact this attack had to you, and then the company can able to contact the insurance, find solutions, protect itself, isolate these machines. In threat intelligence, it's important. Like I used to work in threat intelligence, which we actually were providing the feeds to the companies. So we need to tell them these types of attacks. Let's say this gang are behind this behind blueprints. Like when we're dealing with, let's say, China, we know that they are always behind the blueprints of the company. When we go with, let's say, North Korea, they are more destruction or money. So they were behind, let's say, Bangladesh banks and stealing money. So we have to tell them that. So we try to find what's the reasons behind this attack, what other samples they connect to, and so on. So mostly you get the questions from the other team, and it's very important to know how to get these questions answered as fast as possible and as accurate, of course. Yeah, you have something to say, right?
No, that's pretty much answered my question.
Perfect. So for here, we kind of understood how it works, but we still didn't look at the square revealed function. We actually went very fast on it, but now we know that this function is actually happens when there is a click on any button. So let's see what actually it does. So here it takes the column and the row. It says if this bomb revealed, if it's a bomb. How it checks it's a bomb? It go check like the X and the Y, okay, the cell, the row, and the size. And then here, if the mine present and the mine visible, so here it loops in all of them. See, check all of the map, all the bombs from 0 until 30 as the row, and from 0 until 30 as a column, the whole 900. And it check if there is a bomb there, and this bomb is visible, return true. So there is a bomb revealed. We know that there's a bomb revealed. If it's not, return false. So the only option we can have here is the bomb is the mine is not present or it's not visible. Like we have to not click on any bomb basically and not make anyone present. So this is, if there is any bomb revealed, stop the stopwatch. The application stay for like 1 second, sleep 1000 and sleep 1 second, and then show dialog, the failure pop up, that's like this failure, and then the application exits. That's not what we want to have. The other one, here he gets the revealed cells, he gets the revealed cells, and he add the row multiplied by, this is, we said the 30, the 30, the number of cells. So here he multiplied the row by 30 plus colon. You know what does it mean? He finds like the exact number, let's say, the ID of the bomb or of the cell, and then he adds this to array. And then here, if this mine total revealed empty squares, totally unrevealed empty squares are 0. So this looks like he has a counter up here. And here, this one, if we go to it, he loops on all of the cells. If there is a mine present and there is and it's not visible, he increases it with, if there's no mine present, so there's no bomb, and it is not visible. If it's not a bomb and it's not visible, increase it to 1. Anyway, because I get confused now. Anyway, what's the idea behind it is basically, as it looks like, he counts all the ones who are not bombs, who doesn't have a bomb inside, and they are visible. If they are not visible, like here, if there's one that doesn't have a bomb and it's not visible, increase it with 1. So it means that this is return 0 if there is all the non-bombs have been revealed. You didn't get it?
No, I'm understanding. I'm just trying to understand the how he's getting in from the array. Now, if you can just go over that part one more time.
This array or the function before?
This array here.
Yeah. Let me tell you. So here he checks all of the 900 cells from 0, from the row from 0 until 30, the column from 0 until 30. If there is one cell that doesn't have a bomb here doesn't have a bomb.
Yeah.
And it's not revealed yet. It's not visible yet. So he didn't discover it yet. Increase this number with 1. This is a magic number. He used it to return. So he returned the number of cells that is not bomb and is not revealed yet.
All right. So he's using the return value to then also he's getting the value back. He's returning it to this previous function, and then we have not yet got to what he's going to do with it. So yeah, you can continue.
Yeah. So what it does, he check here if it's 0. So it means that he needs all the cells that doesn't have a bomb to be revealed. That's what he's checking here. So what he is doing here, after it says that after we revealed all of them, he stopped the stopwatch again, and then he slept for 1 second again, and then he showed a success pop-up, which we didn't see yet. And with this get key, so this is what we want. This is what will get us the key for the challenge. And it takes the revealed cells. This revealed cells is the array of all the revealed cells. We have it here. So wherever you click, he saves them in the revealed cells. He takes them here, give it to this one, and then he show a dialog based on this revealed cells. So let's see what this get key is about and what it does with the revealed cells. First, it sorts them out, and then it creates a random number based on this. Just one thing to mention about random numbers. People think that when you use a random number in an application, it actually creates a random number. The truth is not. It's not random. It's actually, you give it an initial number at the beginning. Let's say you give it 5. It will create a random number like 15. Then the next one will be 30. And then the third one will be, let's say, 25. Every time you give it 5 as a start, it will always get 15 and then 30 and then 25. It will be always like that. It will never change. So this is not really random, as you only give it the same starting point. It will be exactly the same every single time. Anyway, here he takes the random number. He takes as a seed, as a start. They call it usually seed. He takes the revealed number, the first one, and then he modify, do some calculation, and then take also the second one, do also some calculation, and take the third one. So basically, what he's doing here is that his random number generator is based on the revealed cells. So whatever comes next, I think we'll always need the 3 revealed cells, the first one, the second, and the third, to be able to get the key. Even if we have here the algorithm, even if we reverse the whole algorithm, maybe we don't really care. But if we're able to reverse it, anyway, we will need the first revealed cells. So this is basically the whole application, how we can get the 3 revealed cells. What do you think, Alexis?
Well, as you mentioned, there are 2 ways that you can go about it, and the second one is what I'm waiting to hear from you. But one of them is, of course, reverse engineering the algorithm. So I'm not sure what you would prefer in this case. So I'll definitely want to hear that from you.
That's true. There is the second way where I want to do it, the secret one. I like it for the graphics of it. There is also another way, which we'll mention after, which is actually we can try to find how he actually set the cells. Like there's for sure a code that have set the cells to be the safe cells, and there's others who have a bomb. So I think we can go with that, but I will go first with the other solution. The other solution is quite interesting idea. So we have seen here if we go back to the main form, the construction, we have seen here there's the minefield controller, which takes the minefield. And basically, we go here, we have seen a function like paint function, right? This paint function paints all of them. And this is a very visual thing. We can know what is the bomb and what's not. What if we decided, that will not make it printed as blank, all of them. We can make it painted like as they are all visible, even if they are not. And we try to see how it will go. So here we have, if this data source is visible, paint either a bomb or safe. Else, blend if it's flagged. We can actually here go right click on edit method in C#. This is what really good about this application, that you can edit the code in C#. It compiles it and modify the code in the IL language, in the intermediate language that Microsoft is using. So you don't have to really go with the assembly. So like, let's take a look at the IL language. If you go here, you see here the IL language here, like call a function here, like load a register, load an argument, call. It's very hard to read it this way, but this way is much easier. It's like a real code, right? And it's able to compile and decompile perfectly as an application. So we go up here and we can modify that code. We can say, okay, let's actually say, okay, here he printed when it's visible. We can make it he painted if it's not visible. So we can just add not this exclamation mark. So paint it if it's not visible, paint it like that. And then, sorry, I'm not seeing from the screen. Yes, compile, and it will compile it this way. But if you run the application, it will not run successfully without saving the file. So we need to first save the file. So file, save module, and then we save it. Let's say we save it with Minesweeper, let's say 2, and save. Okay. It compiles it. It's now running. We can even like. We can even delete that one totally and load the new one. See how it looks like if the code has been edited. We go to the Minefield controller. We have modified this function. Yes, it's edited. Let's run it and see how it looks like. So Tararan, we have them all. Yeah. We have all the bombs up here. And now we don't have to click on the bombs. We know exactly where's the safe boxes. And the safe was like, the safe image was like 8. So here's one. Here it become the opposite picture. It become like, because it become visible, it's painted as blank, So it's like the opposite. And then here, and then there. And we have one.
All right, so that made a lot of sense now, and that was very, very well explained.
Thank you. This is one solution, right? I like the idea of like some people like they go. Some people like I wouldn't say this word, but like let's say the people who are more like serious, they want to take everything. It has to be like that. I have to know exactly where he sits. Sometimes. In some malwares, it's really hard to go the straight way of analysis, but you can set a breakpoint and then trace back or do another solution going around. And this is one of them. Like we didn't see where it actually sets the cells, but we were able to batch the code. Some people will think, maybe I can check the memory and dump the actual list from the memory and see where's all the falses will be like all zeros, and then there will be like 3 ones, and then I will know what's this cells, the ID of that cells, and then I will know where's the row and the column. This is another idea.
So you've just explained that really, really well. And the other question that I have is, and I've been having for quite a while, is when you have different individuals essentially analyzing a piece of malware. It is very possible, as you've mentioned, that they would take different approaches to it. Now, depending on the urgency of the situation, is there a preferred way of going about it, or is it all dependent on the particular person performing the malware analysis?
To be honest, I would say there's like when I used to work in Symantec, there is different people has different things that they different techniques that they are fast in it. Like for example, for me, I used to like IDA. If you give me static like code analysis without running it, I would analyze it very fast. But if I will run it, I will analyze it slower. This is different from another people. But usually, when you are doing an analysis, like for when you want to do it fast, the first thing is to rely on automated tools. You have Cuckoo Sandbox. We have like in big companies, they have other sandboxes or even more developed. So this is the first way to get into the actual map. You can know what files it drops, what activity it does. Now you only what you want to do is to, okay, I want to just check what's happening here. Okay, I know there's a communication to that URL. I just want to know what's happening there. So I set breakpoints there and just dig in this point. So mostly you go into digging into exactly the points that you really want to analyze. This is the fast approach in general, whether it's dynamic analysis or static analysis, whatever the technique you want to use. So yeah, I hope that answers your question.
Yes, it does. Thanks. That was very well explained as well.
Thank you. So there is one function we didn't talk about, which is the allocate memory.
Yeah.
And back to this one. Here we have, actually, this function is quite interesting. I found it, I didn't see it at the beginning when I did the analysis, and I was like wondering, like, sorry, here the main form, the constructor. I was wondering like, okay, like I know how to get this three cells, but where he sets the three cells? And I discovered he used like kind of a steganography, like you can say it. So basically, allocate memory is not a function that allocates memory. If you go here, here's the allocate memory code. It doesn't have anything that calls any function to allocate. It actually loops on the cell and it takes the minefield. So here what it does, it goes from 0 to until the limit, the 30, from 0 to the 30, so the whole rows and columns. And then it takes, the flag is usually true, and then, okay, he takes the number, back. And then he go into valloc types. If it contains this row and column, the flag is false. What this flag is used to. Then he goes into a function called garbage collect. People who use C# and they are so much into object-oriented programming, they know that garbage collection is kind of some basic functions of freeing memory and so on. So he's still using some words that gives you the feeling of it's like an allocation. Okay, we check what's garbage collection. Garbage collect, it basically sets the mine's presence. So it sets the bombs. So it sets what's safe and what's a bomb. So this is the one that we're searching for, actually. It's not a garbage collect as he's trying to say. And he set the flag. So what is this valloc types? If we go to valloc types, it's basically 3 values, page and bool and reserved. And we can see here they are very big numbers. What is this numbers again? Okay, this is the number. And then if this contains this drive valloc type, what is this function? So it takes the row, the column, it does some mathematical, it multiplies the row by 30 plus colon, and then this is, I think, the value of this operator is, I think, for not logical gate that sets the flags from 0 to 1 and 1 to 0. So he basically calculate the row, multiplied by the 30 plus colon, take the NOT of it, and return. This is the what drive valloc type. And then it returns this value. If it's contained in one of these values, if it's returned one of these values, it sets the flag to false. So it sets it to be safe. So there's no bomb. And then here, it basically sets this as a safe cell. So here, what we can do actually is that we can set a breakpoint into each one of these, or we can actually, without setting a breakpoint, we can just go to this one and try to take, go to this array, take these numbers, do the NOT, divide them by, or like trying to, like do the opposite of the math, trying to get the row and the column. And once we get the row and the column, we can get actually the three cells. I will leave you the people to do the calculation by their own. We'll not go into the deep into the calculations, of course, but you can get the idea, right? You can reverse this part, you can reverse this function, try to do the math and get the actual three cells that we have used. So this is two ways of solving it. There's more ways, as I told you, there's memory dump, but there's so many other solutions, whatever the approach you will take. And yeah, this is the whole exercise. So I hope you guys enjoyed it, and I hope it's an interesting one, just fun and simple.
Yeah, definitely. This was really informative and also very enjoyable to see how some of these programs are set up. I do have one last question in regards to the allocate memory function. As you said, it's written to sort of throw people off, and it does something else. Is that something also very common with malware, where we have a function that may look like it's doing something, but then it does something totally different?
I wouldn't say it's very common. It's not like this approach, because when things looks in assembly, everything looks suspicious, right? So you don't usually think about, like, the ability of doing steganography this way is not common. Also, when they do, like when there's .NET malwares, this technique is also not common to use this type of steganography. Maybe it's appeared like here and there, but I don't, like, there's nothing in my head that says like, yeah, there was one malware that did that. It's usually not common. Usually like hardcore obfuscation, all the variables with weird names and everything is actually, destroyed. This is the approach they mostly use.
All right, so that was the last question that I had, and I'm sure a lot of the viewers will have a lot of their questions that they will post in the comment section. So you can check out Amr's links. They will be in the description, as well as the link to his webinar and a link to his webpage. They will all be in the description, and the annotation will be up shortly as well at the beginning and at the end of the video. So you can also end off if you want to as well.
I actually, I would be happy to see what people think about this, what they want to see in other videos. Do you want to see real malwares, maybe some things that teach them something like in real malware, or more CTFs and more challenges? Like, let me people know like what you think, what you really want to see in the next videos, and would happy also to know your feedback about that video.
All right, so definitely, guys, thank you so much for watching. If you have any questions in relation to this video, please leave them in the comment section, and you can also contact Amr on his social networks, which I said, as I mentioned, will be in the description section. So that's going to be it for this video, and I'll be seeing you in the next video.
See you, and thanks, Alexis, for hosting me. See you guys in the next videos. Bye-bye.